Hi students, problem number 7. A train moves towards a stationary observer with a speed 34 meters per second. The train sounds a whistle and its frequency registered by the observer is F1. Actual frequency of the whistle is not given. What is the frequency registered by the observer? The apparent frequency is given as F1. Keep it in mind. Okay. If the train's speed is reduced to 17 meter per second instead of 34, if the speed is 17 meter per second, then the frequency registered by the observer is F2. Naturally, it will be different from F1. So keep it in mind, both F1 and F2 are the apparent frequencies registered by the observer. F1 is the apparent frequency registered by the observer when the train's speed was 34 meter per second. And F2 is the apparent frequency registered by the observer when the train's speed was 17 meter per second. Then, if the speed of sound is 340 meter per second, find the ratio F1 by F2. Very interesting numerical problem. It is repeatedly asked in different forms in different years of the competitive exams. So let us try to solve this problem now. So in the first case, okay, case 1. Here the velocity of the source, that is the whistling train, is given as 34 meters per second. Okay. Next, the observer in this case is at rest. Medium is also at rest. Then the velocity of sound V. So this is given as 340 meters per second. So in this case, the apparent frequency F dash is taken to be F1. Okay, where F is actual frequency. We don't know. Okay, the actual frequency of the whistle is F. So the apparent frequency is taken in the first case as F1. So as usual, now we will write F dash, that is F1, is equal to the actual frequency F multiplied by V plus V medium minus V observer divided by V plus V medium minus V source. In the first case, I will take V as 1. Okay, so this is V as in the first case. I will take the suffix V as 1. So this Vm is 0. Vo is also 0. Therefore, what is F1 is equal to F multiplied by V divided by V minus Vs1. So F1 must be equal to F into V. The velocity of sound in air is 340. So this is what 340 divided by 340 minus the speed of the source is 34 meter per second. So this is 340 minus 34. So in the first case, the apparent frequency listened by the observer is F1 is equal to the actual frequency is not given. So let it be as it is. So this is F multiplied by 340 divided by 340 minus 34 is 40 minus 34 is 6 by 306. So this is equation 1. Let us keep it as equation 1. Now case 2. So in the case 2, only which factor is going to change is the source, velocity of the source. Instead of 34, we have to take 17 meter per second. So the velocity of the source in this case is taken as Vs2. So that this is now 17 meters per second. All other values are not going to change. Is it not? Therefore, now F2 is equal to the apparent frequency listened by the observer. The second case is taken as F2 instead of F1. Okay. So F2 is equal to F into V by V minus Vs2. So this is a V divided by V minus of Vs2. So that this is equal to F into 340 divided by 340 minus 17. Okay. So this is now equal to F into 340 divided by 340. 40 minus 17 is 23. So this is 323. Therefore F2. So this is our equation 2. Very simple. Very, very simple. So in the first case, the apparent frequency listened by the observer is F1. That is F into 340 by 306. In the second case, the apparent frequency listened by the observer is F2. In terms of the actual frequency, it is F into 340 by 323. What is asked here? The ratio of the two apparent frequencies, F1 by F2. Therefore, now F1 divided by F2 must be equal to what the ratio of these two. So, this is 340 into F divided by 306. This is F1. This has to be divided by F2 or multiplied by reciprocal of F2, isn't it? So, into 323 divided by 340 into F. So, this is 340 into F. So that this 340 and F get cancelled, so that this is equal to 323 divided by 306. So this is 19 multiplied by 17 divided by 18 multiplied by 17. 19 into 17 must be 323. Similarly, 18 into 17 must be equal to what? 306. So if you check with the calculator, you can find out that the 17 can be cancelled. Okay, so this is equal to 19 divided by 18. Therefore, F1 by F2 is equal to 19 by 18 is the answer. So very interesting problem. So how to deal with this problem? Understand carefully. Understand very carefully. Read again and again till you understand. Write the given quantities. Okay. So you have to apply the general formula. General formula every time I am writing the velocity of the medium also, because in some numerical problems the wind is opposing the sound will be given. So in that case Vm will become minus Vm also. So better you write the general expression always with respect to the positive x-axis. So any movement along the positive x-axis means this equation. Any movement along the negative x-axis means all negatives will become positives. Understand that? So like this for case 1 you find out F1. Similarly, applying the same equation for case 2 you find out F2 and take the ratio. It is found to be 19 by 18. I hope you must have understood well. Fine.